welcome back to the second video in our series. If you haven't seen the first video, you're probably okay. If you just want to walk in here, chapter 2 happens all the time. Just beware, there's a previous video and more to come. So, excuse me, this session we will be talking about engine basics. This is going to be Engine 101. We're going to be focusing mostly on American V8 blocks. There are others out there. I encourage you to take a look and see what the difference is between a V8 and an America versus like a flat inline 6 coming out of Japan or something like that, or God forbid you look at a Wankel rotary engine. All very different, but the concepts remain the same. We're going to get into the basics, though, of the kind of engines we're going to be tuning in this course. I will say again, this is Engine 101. I am assuming you know nothing. I think, what was it in Days of Thunder? Everybody laughs at Tom Cruise. You know, he knows how to drive them, doesn't have any idea how they work. Let's not laugh. Not everybody knows this stuff. This is meant for someone who, again, is brand new. This is someone where, if you have a family member who doesn't know much about this and you're super into it and they have no idea why, this is good for just sharing the gospel of the thundering American V8. And so, without further ado, I will get into it. In this lesson, we will be looking at what is internal combustion. We'll be looking at the anatomy of engines. We're going to be discussing the block. We're going to be discussing the rotating assembly. We're going to look at engine breathing, intake and exhaust. And we're going to look at engine accessories. And if you are in the know on engines, you know that we're essentially talking about the short block. And next time we'll be talking about the long block, right? But this is just walking through short block. If you don't need this info, you can move right along, right? But I like creating a guide that from the ground up begins with the basics. And so the basics are this. What is it? If you're brand new, an internal combustion engine is a huge hunk of metal. It is a dynamic system. It has inputs and outputs, and it produces power. The inputs are air and fuel. It has a process it undergoes where it compresses the air and the fuel. It ignites it with a spark plug, and this results in power being produced along the crankshaft, which then it moves through various mechanisms. So these engines work in a variety of different conditions. It can be cold, right? We know there are cars that work in Siberia. These engines, they can manage it, right? We know there are cars that work at the equator. They can handle warm air as well. We know that they work in the rain. All of these conditions in modern engines are accounted for in the ECU. And I mention it here and now without any specifics because later on you will need to account for these different weather conditions, especially barometric pressure and heat. So prick your ears up. We're going to be talking about this more later, right? But yeah, variety of conditions. Internal combustion engines have been around for a long, long time. I think the history is, 1806. Credit goes to a couple of French engineers who were playing around with exploding dust, is what I hear. You can go check it out on Wikipedia. I'm not going to stop you, right? There's all kinds of info. But these engines, they've been around for a long, long time and originally started with single cylinders and then moved through different progressions, right? We know that in the 19th century, trains, locomotives, and steam power where a lot of focus was, but the internal combustion has been around for some time. It was really, I think, in the 1880s that major development began to happen, and German engineering and all that, and ultimately manifesting in the early 1900s. Mass production begins with Henry Ford creating the Model T, right? So there's a very, very rich history here with Ford in particular that we are joining and becoming part of. I highlight all this because I'm a sociologist and historian of technology and my other professional life. If you're truly interested in this stuff, there's a fantastic book out there called Leviathan and the Air Pump by Steve Chapin, and it examines the true roots of the internal combustion engine going back to 1600s, when the critical invention of the air pump and the discovery of the vacuum becomes incredibly important. And Boyle's law, ultimately, PV equals nRT, right, that equates pressure and volume to temperature, is something we will again deal with a lot in this course, right? It's something, in fact, that governs all of what we do with tuning the engine in a way. So if you want to really nerd out and check out some of that history, it's kind of interesting. Some spoilers. Vacuums concerned the church greatly because the idea was that the God and souls were everywhere. And so if you had something in the universe that was a hole where nothing was, you've just negated the existence of God and souls. I'm not making this up. This was of deep concern to people back in the day. So kind of fascinating that engines now have this major crisis as something they were rooted in. But I digress. Let's move on. Looking at engine anatomy. The block. Okay. This is a V8 block. It's from a Mustang GT. It has a lot of pieces on it, as you see. If this looks scary and you've never really looked at one before, that's cool. We're going to go through it. If you could draw this from memory, I don't know why you're here. But it's always helpful to review some things. So, the block is the main engine housing, all other components attached to the block. It is a large metal piece. It is solid. The main part of the block. It's usually forged from, for a long time, it was cast iron, which of course is prohibitively heavy, but it's very strong. A lot of blocks now are machined from aluminum. And this is, like aircraft, space age aluminum. This is serious stuff. It can hold up to the intense pressures that the internal combustion engine produces. So it has to be a very, big, stout piece of metal. Starting to really dig into it, this is what the block looks like when it's cast. It doesn't have any components. Of course, this one is very finished. It has been machined, polished, brought into incredibly tight tolerances. The tolerances on these engines are, we're talking, there's something out there called a feeler gauge. And if you ever get a chance to touch a feeler gauge, the distance of some of these components from one to the other is staggering, the degree that they're machined. So just to say, it looks like it's just sort of this hunk of steel here, right, or iron. An incredible route, right? Tens of thousands of hours of man labor go into making sure these things are brought into extremely tight tolerances. If you've ever seen mechanics working in engine bays, you probably would never see a naked block like this unless they're not working on it. The tolerances are so important on these things that usually you take things up and make sure that no sort of little grit. If you were to get a grit of sand in with your piston, for example, it would ruin it, right? So just be aware, I'll highlight now, cleanliness and organization around working on these things is incredibly important, especially as you get inside the engine. But this is the block. The cylinders, if I can bring my mouse here, these 4 circles here on the left, the big ones, those are the cylinders. That is where the combustion itself is actually taking place. The cylinders of the block can sometimes be reinforced or sleeved if we need to do various things. You can go get a block from a junkyard that is in its stock form, and if you are a capable machinist, you can bore the cylinders and increase the volume. And we'll talk about why that's a big deal later on. You can also increase the length of the cylinder and make something called a stroker motor. There's all kinds of things you can do, but the magic happens in the cylinders. If you're not in the know, when we refer to engines as like, the Mustang is a 5.0. It's a 5-liter engine. The reason it's a 5-liter engine is because that is the volume of all 8 cylinders combined. So that's 5 liters of volume available in which we can mix air and fuel and produce power through an exploding flame front. And we'll get into all that in a bit. But that's the magic, right? Let's demystify why we call these things that. It's in liters now. You'll see sometimes it's in cubic inches. If you look back in the day, if someone says, "Oh, I have a 383 block," right? It's 383 cubic inches. Just be aware. Some of the older legacies refer to that way. You will see in this block that there's lots of little holes, and these little holes do all sorts of things. Some of them are mounting points, some of them are for sealing things up with seals. Seals are a big deal. Metal to metal will not hold air well, if at all. So if you want to, later on we'll talk about the cylinder heads, right? It's this big piece that goes on top of the cylinders. We have to put a gasket in between those, and then we have to use all these little mounting holes to really flush this up. The reason for that, and I'm going to get into the water jacket in a minute. Some folks don't know this, but the engine, when it is operating, actually produces a vacuum state. It sucks air in like through a straw. We're going to talk about that when we get to the intake. So that's the reason why a lot of these seals are so important, is because it makes it airtight, liquid tight. And we're not talking about, a basic sort of Band-Aid here. We're talking about under massive loading conditions where there's all kinds of temperatures, pressures, things like that. These things need to stay sealed. If they don't stay sealed, all sorts of mayhem begins to happen, including the dreaded oil leak, right? So I've been through this personally. It's not fun. Anyway, that's part of what all the little holes are used for. Other purpose, though, of a lot of this is because we want to be able to flow coolant through the engine, and that is referred to collectively as the water jacket system. There is a pump that sits on the engine. We're going to look at it in a minute, and this river of water is coursing through the engine at all times. It has to, for the health of the engine, because the engine needs to come up to what is called the operating temperature. For my 7th generation Mustang, my operating temperature is about 230 degrees Fahrenheit. You will notice that is higher than the boiling point, which is 212 degrees Fahrenheit, just to give you a sense of the temperature in this thing. Other engines will often run at something like 200 degrees Fahrenheit, right? This is why, if you've ever opened your hood, you will see something in there on the coolant as a little cap. And on the cap is a stick figure guy getting his face melted off by this burst of steam. That's why, right? It's because the operating temperatures of these blocks is pretty high. That's why you can be driving in the desert, taking in air that's 100 degrees Fahrenheit, which seems impossibly hot, but relative to the temperature of the block, it's actually cooler, right? So, yes. Water jackets, just be aware. Not everybody knows that, right? But it's almost like a circulatory system, like blood flowing through the body, right? It serves a purpose. Yeah. Okay. Moving on. So if the block is static and immovable, doesn't do it, it doesn't wiggle at all, right? The rotating assembly is the exact opposite. The rotating assembly, if the engine is operating, is constantly moving. And it has a lot of parts that you probably have heard of. Let's go through some of them. Again, moves all the time. Pieces of the rotating assembly. So there's the big boy, the crankshaft. The crankshaft is probably the single most important piece of the automobile, right, aside from the block itself. Because this is the thing that all of the power is exerted on by the combustion itself. And the combustion is the exploding event, right? The power travels into the crankshaft ultimately, and that crankshaft spins inside of the engine block. If you've ever looked at a car and you've seen that you have your speed, you're doing 60 miles an hour down the road, there's another key dial, right? The RPM, revolutions per minute. If I'm at 2,000 RPM, it's very different than 4,000 RPM, right? Or a cruising RPM in most cars. Economy car, for example, would be something like 1,200, right? My 7th gen Mustang likes to cruise at about 2,000. because she is a salty girl, right? We'll get into that later. But what that revolutions per minute is counting is the revolutions of the crankshaft inside the block. If you didn't know that, now you do, right? And it all connects up out to producing output out the engine via the flywheel. The pieces in the middle are the rods and pistons. And let's, nope, we'll get into it now. Actually, wait, I'm going to come back. The pieces here, so this is our crankshaft. Nice exploded view. These are your pistons. They are these dome-like structures. If you were to flip these over, you will see that these are mostly void. It's empty space. It's not that this is a solid cylinder of metal. Quite the opposite. It's a solid surface up here, but down in the innards, it's pretty void, and it has spaces to connect to our good friend here, the rod, right? The rod, there are 8 of them and 8 pistons for all 8 cylinders. Each cylinder gets a rod and piston. The rod connects to the piston itself here, and then this large piece connects on the crankshaft. You can see it has these different points of engagement where these rods connect. That's how it works. Going back here, the crankshaft is held in the block itself with some very special devices called bearings. And the bearings have to withstand the friction of a piece of metal moving at 6,000 rotations per minute, which is crazy fast, right? So the bearings need to be able to hold up to all that pressure. They basically have to be impervious and bulletproof. And you'll notice here, there are these large sort of, I don't know what shape they look like, right? But they're these like widening, big, heavy pieces. Those are to counterbalance the motion of the crankshaft as it's spinning. If you were to spin this thing at 1,000 rotations per minute without these weight offsets, I should know the term. It'll lose me the moment. The car would shake itself to pieces, with you along with it, right? So these counterbalancers are there to help make sure the crankshaft still feels smooth. The flywheel connects on one side of the engine to the transmission and other portions of power. We'll talk about that in a bit. On the other side of the flywheel, there's often sometimes something called the harmonic balancer. That's a nice big heavy piece of metal that offsets the shimmy of this thing, if you will, as it rotates, and it makes the whole thing feel smooth, even though it's, frankly kind of bonkers to think about pieces of metal this big being moved around by little explosions, and we just sit within 3 feet of this thing and don't think anything of it. Kind of amazing. Getting back over here, again, we talked about how we have a crankshaft, we have pistons, we have rods, and so again, I will say, I'll add this, right? Huge amounts of force are being applied to this crankshaft, and as it moves in the engine, because of the fact that there are little explosions happening all the time, that heats things up intensely, but also there's friction, right? The physicist's most hated nemesis, aside from finding a grand unified theory. If you know what I mean, congrats, you're in the club. These things get wicked hot. And so for that reason, we use oil as a lubricant. The rotating assembly essentially sits just above an oil pan. That oil pan has a pump. It pumps oil through the block, right? And also it's just kind of sitting in it, right? And this crankshaft has to be lubricated at all times or it'll melt, right? Or it'll reach a point where the metal becomes prone to fatigue because of the heat, and the last thing you want is for that crankshaft to snap. Or you can have a piston run afoul and scratch up cylinders, and then you get some blow by. We'll talk about that later. Or you can have the rod bend, right? And that if one of those things goes, man, you've blown your block, right? And that's the other worst case scenario, right? Is you actually put a crack in the engine block itself. You will hear people out there in the world of car modification enthusiastically talk about how they have something called a fully forged rotating assembly. And that is a situation where if you were to get a 400 something horsepower Mustang, it comes with a rotating assembly with it that is pretty stout. You can probably do some regular power adders like cooled air intakes and long tube headers, right? You can probably even make your throttle body bigger, right? You can start putting power adders on. You reach a point though where if you're going, I would say, I don't know what the magic line is, but let's say 20%. If you start going above 20% of what the engineer rated that rotating assembly to handle in terms of the forces it is subjected to and the power it produces, once you get above that 20% mark, you enter a danger zone where you're stressing it and it'll fail prematurely, right? They're meant to last. I mean, Ford makes these things with a warranty. They know it should last 100,000 miles. You start loading this thing up, what if you only get 60,000 miles out of it? I mean, you'd be really beating on it, right? But a fully forged rotating assembly is where we take the whole engine apart, we take out the stock innards here, and we put in a new crankshaft, pistons, rods that have gone through a different set of metallurgical treatments that have hardened them up in a forging process, and they can take dramatically higher loads. So a stock crankshaft maybe can only take 650 horsepower, right? These fully forged crankshafts, though, I mean, you're talking 1500 horsepower, right? That's why you get one of these things. If you're not doing much to your car, you're probably good. You don't need to do this. If you're going to put a blower on, though, and put, 10 psi through this car, if you don't understand what it means, we'll talk about that later, you'll blow the block apart, right? So just be aware, one of the most desirable things you can do for massive power, the kind where you see at the drag strip, right? People will tend to get fully forged version of these that are stronger than the stock ones. We are very lucky, if you have an S650 Mustang and you're here to learn to tune it, that the innards of our rotating assembly are in fact pretty stout. I think I've heard even that Ford out of the box gives us a forged crankshaft. Maybe not forged rods and pistons, but a forged crankshaft. And it should be able to hold up to something like 800-900 horsepower with modifications. So the Whipple Super Blower, for example, you're okay with your stock crankshaft. We'll get more into that later on. For this, let's move on. Air intake. Okay. So on top of the engine, there is something called an intake manifold, and that manifold has runners. And if I get my mouse over here, oh, I guess you can't see. Oh, no, you can. Perfect. Great. So these are the runners, and this would be the main intake. This is one kind of intake manifold. This is this is a Boss 302 intake manifold, widely considered one of the most desirable. Here you see there's a big hole. This is where air comes in, and it sends it to these 4 runners down one side. There's 4 runners on the other, right? So it makes 8 runners total. This is how the air is getting into the engine. You remember from the previous video I said with an engine there are only ever 3 things really you need to worry about: air, fuel, and spark, right? So this is the air component. And let's see. There's also something that sits on top here, on top of this large hole, which you can think of as a large straw. Or if you've ever been snorkeling, actually that's a better example. It's like the car's snorkel, and it's pulling all its air through a set of tubes. This is the hole where we first connect to. On top of that is something called a throttle body, which we'll talk about more later. That's where we regulate how much air is going into the engine. And ultimately a set of pipes that are plumbed in your car where we actually bring the air in. This air that we're bringing in has to be measured very carefully. the measuring is sometimes called metering, and you will hear a classic tuner aphorism, right? This car, you cannot have unmetered air enter the engine. And the reason for that is because we'll look later on at some fuel consumption, right? We need to send in the appropriate amount of fuel to meet our air, right? And so the car will literally measure how much air is coming in, and based on that measurement, in real time, the computer will compute and say, if we're bringing in this much air, we need this amount of fuel. And that's what's going to go in our cylinders and produce the power, right? So the intake manifold is a dramatically important area where the air charge begins here, right? And so there's a lot of attention we will pay to this particular portion of the engine, and in our logs we will be looking very carefully at a couple of things. One is our MAF sensor and the gram seconds of air we're bringing in, but also brain fart. My intake manifold pressure, right? We want to know what the pressure is of this thing at all times. And remember, if an engine is running because air is being sucked through it, in its natural state within the block itself, there is a vacuum-esque condition, right? So it is breathing air all the time, even at idle. So just to say. Moving forward, of course, we also have an exhaust. There's my picture. Exhaust, like the intake manifold, right, has a single intake and sends it down 4 runners. The exhaust uses headers to collect the exhaust from each of the cylinders. This, I think, is a stock Mustang header. Yep, and you can count here. There's 1 pipe, 2 pipes, 3 pipes, 4 pipes. And so these are connected to the sides of the engine, and after the gasoline is burned along with the air, it sends it out this header assembly and ultimately to something here called the collector, right? And the collector connects over here to our exhaust, right? And this is the classic, most people know what this is, right? The byproducts, right?